Hello, advanced algebra students. Welcome back to another video lesson today where we continue on with our exploration of triangles and our tangents, cotangents, things of that nature, where we explore the law of sines and the law of cosines today. It might be a little bit longer again, so sit down, buckle up, sit back, pause the video as much as you need to. First, I would pause the video right here. Make sure you've got an accurate unit circle. Best picture I could find of what really happens is right here. So again, this was the unit circle. This is the complete unit circle. Again, noticing these different relationships, how quadrant 1 is just repeated in every other quadrant. Every angle is in relationship to the x-axis. And we use that with unit circle when we're trying to find exact values of cosines and sines. Now, what we've been doing a lot of has been using that for all of these different special triangles. Right triangles, as a matter of fact, where we could use the Pythagorean theorem to help us find a missing side. We could use one of the trig functions to help us find angle measures or a missing side, and special right triangles to help us find a missing side as well, which is where the unit circle came from. Right? So all of these three were used to find missing sides and missing angles of triangles that were very specific. But now we've got a problem, right? We don't only have those types of triangles, right? What's the issue in these two? Yeah, these aren't right triangles, right? This is 15, 20, which means this one up here on top would, have to be 180 minus 35, 145. And clearly the one on the right-hand side, since it's 114, neither of these can be 90 for a triangle. So what happens when we're asked to find missing sides, or angles perhaps, even inside of triangles that aren't right triangles? Because we do have to be able to do some things with right that aren't right triangles, okay? Over here, we have something called law of sines. Over here, we have something called law of cosines, all right? So let me try and break this down. Let's focus on the law of sines first. This is coming from page 13 of your packet. We can use the law of sines, which I will give you a specific formula for in a moment, whenever we have two angles and an opposite side. Two angles and opposite side, right? Notice, if we focus on the law of cosines, we have two sides here and the angle in between them. That's when we use cosines. If we have one side and two angles, we're probably going to be using, in here, the law of sines. And what we get is we get an angle and its opposite side, an angle and its opposite side that we are looking for. Right? Same thing even in this picture. I know this angle measure down here for A. We might have to calculate it, but we know it. Opposite side, we could find an opposite side. So here's what the law of sines represents. In any triangle, more specifically ones that aren't right triangles, because we have easier ways in right triangles, but in triangles, we can set up one of these proportions. I can take the sine of angle A over A equals to the sine of angle B over side B equals the sine of C over its opposite side. It's all about that relationship to its opposite sides. Basically, you're forming an X, if that makes sense. I'm forming an X by setting up a proportion that will help me solve for that missing side. All right, let's take a look at what this looks like in an example, though. All right, this is, again, page 14 of the packet. I have this triangle, clearly not a right triangle, because I've got 100. And so we're trying to find side X. So what I can do is these two are in a relationship, and these two are in a relationship. The sine of 42, how would I write that the right way? The sine of 42 over its side, 56, equals the sine of 100 over X. Okay, the sine of the angle over its side equals the sine of the angle over its side. So once we have that set up, this goes back to solving proportions. We cross multiply. X times the sine of 42 equals the sine of 100 times 56, or 56 times the sine of 100. Remember, sine of 42 is nothing but a number, so we're going to divide by sine of 42 to both sides. Now, this is where you've got to be very careful about how you're ending up typing this excuse me, into Desmos. You have to make sure that you're paying very close attention to where the parentheses like automatically insert. Okay, so 56 sine of 100 for multiplying this way divided by sine of 42. Let's go over to Desmos, and again, I'm going to use the scientific one just because it's a little bit easier to type in here. We've got 56 times the sine of 100. Close that parenthesis. Notice how I closed it. Then hit the divided bar, or the question mark on a keyboard, the sine, parenthesis of 42, and close it, and we get 82.42. So be very careful about how you use those parentheses. 82.42. All right, let's try another one. See if you can't set this one up. Pause the video here and see what you get for an answer. Okay, sine of the angle, so let's go sine of 20 over its side, its opposite side here, right? There's the relationship, equals the sine of that 15 over 7.5, the relationship with that side. So there's the x that we created. Cross multiply. 7.5 times the sine of 20 equals x times the sine of 15. And again, if we're solving for x, we have to get rid of this number, which is sine of 15, some random weird decimal. And so we are left with punching this left-hand side into Desmos. And again, make sure if you are using your own calculator that you don't have it in this RAD or radians mode, because it changed that one that I still had in there. We want to make sure that degree is highlighted. I did notice on the last test that a few of you did have radians. So it was 7.5 times the sine of 20 all over the sine of 15. 9.91. X equals 9.91. So that's the law of sines. Sine of the angle over its opposite side equals sine of an angle over its opposite side. There's that proportion. Okay, and again, we use that when we don't have, when we don't have the angle in between the sides. When we have angle, angle, side, or angle, side, angle, two angles and the opposite. Now, what happens, though, when we get a picture like this down here, where we do have the angle in between? Well, what we end up getting is what's called the law of cosines, where we have two sides and the included angle. It's called an included angle. It's in between those two sides. Okay. Keep in mind, this also could be used for side. We could use the formula that I'm going to show you in a moment to find an angle. But we have to, I think the hardest part in all of this for law of sines and cosines is knowing which rule to use. So here's the law of cosines. It's basically this formula right here. C squared equals A squared plus B squared minus 2 times AB times the cosine of C. So you're probably going to want to pause the video here, get my mouse out of the way, and write that down. Now, the nice part about this, and it looks confusing, but the nice part is that the C This is your missing side. We're always going to be solving for the missing side for the most part. Occasionally the angle, but most of the time the missing side. The missing side should be opposite the angle that they give us. A and B, doesn't matter where I put them. They could be A and B flip-flopped. All right, so here's a story problem. A baseball field is determined by a square that has 90 feet long. So this is home plate, first base, second base, third base. In the diagram, home plate is H, first place is F. Suppose this first baseman ran a straight line from F to B to catch a pop-up. And where he caught it, right here, is 120 feet from home plate. So that's this measurement. If the measure of angle FHB is 10, how far did he run? We're trying to find this FB. Right, that's our side C in the formula. C squared equals A squared plus B squared minus 2AB times the cosine of C. So we're basically just filling all of this in. A squared, let's just say A is 90. So I've got 90 squared plus B squared is the 120. Those are the two sides that they give me. Squared minus 2 times 90 times 120 times the cosine of 10. So it's just a matter of trying to figure out what goes where in this formula. But A and B are the two given sides. Cosine of C is the included angle, the angle in between them. So once again, we're going to go back to Desmos. This one's a little bit harder for us to maybe plug in. 90 to the second plus 120 to the second minus 2 times 90 times 120 times the cosine of 10. So notice how that is plugged in, right? That's very, very particular. If you want, you could put a parenthesis out front and a parenthesis out back to just make sure, you know, that's included in that sense. I'll even put a multiplication sign in there. 1,228. So C squared equals 1,228.15. I'm going to leave that over there in Desmos because what do I have to do to find C? We take the square root. So if I go back over to Desmos, I still have my answer there. I'm going to hit enter so that I get a new line. And I'm going to hit the square root button. And then I'm going to hit answer to take the previous answer. So grabbed it and it moved it there to give us 35.05 feet. 35.05 feet is how long he ran. It is very important that you take and plug this entire expression into Desmos. Don't round anywhere until we get to the very, very end. But we're plugging all of that into Desmos on one line, getting the answer, and then take the square root of that previous answer. So that is the law of cosines. Again, where we're trying to find that missing side. They give us two sides. They give us the angle in between them. If you have any questions about law of sines, law of cosines, please make sure that you reach out. Otherwise, try the practice problems today, see how they go, and we'll connect again in our next video. Until next time, everyone, stay safe.